Welcome to This Explainer. I am so thrilled you're here today. We're going to be playing the role of data detective. If you've ever stared down a massive, unstructured mountain of text and just felt this wave of absolute dread wash over you, the kind where you literally want to slam your laptop shut and rethink all your life choices, well, you're in the exact right place. Because today, we're going to explore how to take that chaotic pile of raw text and transform it into incredibly valuable, actionable business insights. We're turning total overwhelm into pure insight. Okay, let's dive right into this with a pretty high-stakes business problem. Imagine you're a product manager at a major tech company. You've just launched a brand new smartphone, and overnight, your product page is absolutely flooded with 50,000 customer reviews. And of course, your boss wants to know exactly what customers think, like right now. So how do you read 50,000 reviews in 1 minute? Well, the short answer is you don't. No human possibly could.
But a machine definitely can. Instead of a human agonizing over every single paragraph, we can use automated systems to instantly parse through those thousands of reviews. It takes all that raw, messy data and sorts it neatly into clear, distinct buckets. We're talking battery issues, camera quality, delivery problems, customer service, you name it. A computer can discover these major discussion areas in literally seconds, without a human needing to manually read a single sentence.
Here is our roadmap for today's explainer to get us out of all that data chaos. We'll start with the data overwhelm problem, introduce web mining, look at finding truly important words, discover hidden themes, group similar documents, and then wrap it all up with the complete mining pipeline.
Section 1. The data overwhelm problem and why humans need help.
Section 2. Introduction to Web Mining, your detective's toolkit. Look, reading one product review is incredibly easy, right? Reading 10 is pretty insightful. But reading 50,000? That's physically impossible. When businesses are dealing with thousands or even millions of data points, human manual review just completely breaks down. If you're a data detective trying to solve the mystery of what your customers actually want, web mining is basically your ultimate magnifying glass and fingerprint kit. Web mining is the process of extracting valuable information and patterns from web data to gain insights and support better decisions. And specifically today, we're focusing on web content mining. The goal here is simple but extremely powerful. We want to turn raw, noisy web text, things like product reviews, news articles, or blog posts, into actionable knowledge, so you can make much smarter business decisions. So here's the high-level web content mining pipeline. We start right at the beginning with raw web reviews. First up, we clean that data through text pre-processing, which just means removing noise and unhelpful words. Then we get into the really cool mathematical heavy lifting. We use TF-IDF to find the important words, topic modeling to discover hidden themes, and clustering to group similar documents together. And finally, we emerge at the end with clean, data-driven business insights. We're going to walk through exactly how each of these specific steps actually works. Section 3. Finding truly important words. The highlighter. Think of this next step as the algorithm's version of a giant neon yellow highlighter, just picking out what actually matters in a massive wall of text. Now, what's really interesting about this is that it exposes a huge trap people fall into when analyzing text, which is just counting words. Let's think about human counting for a second. If we have 3 reviews, excellent phone, excellent battery, and excellent camera, and we just count up the words, the word excellent appears 3 times. The word battery only appears once. So for only counting, excellent looks like the most important topic, right? But the word excellent tells us absolutely nothing about what the customer is actually reviewing. It doesn't help us distinguish one review from another at all. The machine, however, needs to know that phone, battery, and camera are the true informative topics. To solve this problem, data scientists use this mathematical magic trick called TF-IDF, which stands for term frequency inverse document frequency. Let's break this down a bit. Term frequency, or TF, simply measures how often a word appears inside one specific document. Inverse document frequency, or IDF, measures how rare a word is across all the documents combined. So if a word like excellent has a high TF but a really low IDF, meaning it's just everywhere in the collection, its total TF-IDF score drops, and the algorithm just ignores it. But a word like battery, it appears frequently in a specific review, but it's relatively rare across all the reviews combined. So it gets a high TF and a high IDF, giving it a high overall score. The math automatically highlights the descriptive words and basically penalizes all that common fluff. I really want you to remember this simple formula. High TF plus high IDF equals an important keyword. It's absolutely crucial. A word is only truly important if it describes the specific content of one document while being distinct enough that it isn't just a common, everyday word scattered across your entire dataset. Section 4. Discovering hidden themes. Topic modeling. So we've found the important individual words using TF-IDF. But how do we know what broader themes people are discussing? I mean, if I just hand you a list of 50 disconnected keywords, that's still pretty overwhelming. That is exactly where topic modeling comes into play. Topic modeling is this brilliant technique that automatically finds groups of words that frequently appear together in the text. By using unsupervised machine learning models like latent Dirichlet allocation, or LDA for short, the algorithm actually notices that when people type the word battery, they also very often type the words charging, life, power, drain, and backup. Now, the machine doesn't actually know what a battery is, but it knows mathematically that all these words belong in the exact same thematic group. Let's look at how we actually use this in practice. The computer automatically generates a group, let's call it topic 1, with words like battery, charging, and power. It also generates topic 2 with words like camera, picture, photo, and zoom. The computer discovers these groupings completely automatically, based purely on the data. The human's job is simply to look at these machine-generated lists and assign a label. We look at topic 1 and interpret it like, okay, this theme is obviously battery. We look at topic 2 and say, got it, this theme is camera. We're working right alongside the machine to analyze vast amounts of data in just a fraction of the time. Section 5. Grouping similar documents, document clustering. So far, we've grouped words into themes. But what if we want to group the actual physical documents themselves? Like, what if we want to sort our 50,000 reviews into distinct piles on our desk based on how similar they are to each other? For that, we use a technique called document clustering, and a tree-like structure called a dendrogram brilliantly illustrates exactly how this works. The algorithm calculates the pairwise distances between every single document based on their TF-IDF representations. Documents that are closer together in distance, meaning their content is very similar, are merged first. And as you move up the tree, it continues to merge similar reviews together until distinct clusters are formed. It's essentially automatically organizing our giant collection by grouping similar reviews without us needing to give it any predefined labels. The practical result of this is honestly staggering. We have successfully sorted our chaotic mess of 50,000 reviews into neat, highly specific digital filing cabinets. Now, if your engineering team only wants to read about battery complaints, you can literally just hand them cluster 1. If the marketing team wants to see what people love about the photos, you hand them cluster 2. We've taken total chaos and brought absolute order to it. Section 6. The complete mining pipeline. We've talked about a lot of powerful concepts today. Text preprocessing, TF-IDF, topic modeling, and clustering. Let's see how this detective toolkit works in an actual practice. What we're looking at conceptually are visual workflows built using a software called Orange Data Mining. And what's really incredible about this is that you don't necessarily have to write complex code to do all of this. You can just string these steps together visually. You start with a corpus node to load up your text documents. You connect that to a process text node to clean everything up. Then you pass it right through a bag of words node using TF-IDF weighting to turn that text into meaningful numbers. From there, you can connect it directly to a topic modeling node to discover your latent themes, or even view your top keywords in a word cloud. It's a seamless automated pipeline, transforming raw text data into structured, numerical features that are ready for deep analysis. Which leaves us with one final thought to close out this explainer. Think about your own business, your own projects, or your own research. What hidden insights and actionable patterns are currently buried in your unread data? Now that you know how tools like TF-IDF, topic modeling, and document clustering can do all this heavy lifting for you, it is officially time to stop reading thousands of documents manually. It's time to start mining. Thank you so much for joining me for this explainer, and happy analyzing.